Welcome back, Honors Algebra 2. Today we're going to do some word problems. Let's just look at the first one here. We have, as you drive home from a football game, the number of kilometers you are away from home depends on the number of minutes you have been driving. Assuming that distance varies linearly with time. This is an important little sentence right here. Suppose that you are 11 kilometers from home when you have been driving for 10 minutes and 8 kilometers from home when you have been driving for 15 minutes. Define the variables. First off, it says assume the distance varies linearly with time. That means that distances are y, or our output. It varies based on what the input or time is, okay? Now, I am going to define the variables. I'm not going to use x and y. I'm going to use t and d. But since the time and the distance are, I'm going to write them like this. So time corresponds with x, and d corresponds with distance. So t equals time driving. It's how long you've been driving. And the distances, or d equals, I should say, the distance from home. Now, since it says it varies linearly, that means we can come up with an equation based on the information, just like what you did right before the quiz. If you have 2 points, you can always come up with a linear equation. Usually we write them in slope-intercept form, but you could start in point-slope form and get there. So, first thing, we need 2 points from this information. Well, when t is 10 minutes, we're 11 kilometers from home, so I have the point 10, 11. And when the distance is, or when the time is 15 minutes, we're 8 kilometers from home. So 15, 8. So first thing I'm going to do is find the slope. My slope for this problem is -3/5. And now I'm going to take one of the points and find point-slope form, or find slope-intercept form from point-slope form. Now remember to use the letters you decided to use in the part above. If you decided to use x and y, that's fine, but then you have to use those. I have to use d and t's. So my y, or d, minus, I'll do the 8 and 15 one, 8, is equal to the slope times t minus 15. The reason why I chose this one, well, actually it really doesn't matter which one you choose. There was no big reason. Now you can solve this. So over here I have d minus 8 is equal to -3/5 t. Then this becomes a plus 9. -15 times -3/5 is positive 9. And finally, you get your final equation. We have an equation that models the situation. D equals -3/5 t plus 17. If you want, you could also write a d of t in function form. They're the same thing. But that helps you know what the input and output are. Okay, so we have d of t is equal to -3/5 t plus 17 is our equation. So now it says predict your distance from home when you've been driving 20, 25, and 30 minutes. Well, that's just plugging into your equation. So when the distance, when the time is 20, is going to be -3/5 times 20 plus 17. And you should get 5 kilometers from home. Let's do it for 25 now. Now remember, this is function notation. I'm not multiplying d times 25. I'm just saying I want to know the distance when the time is 25. You guys will get used to that as we keep going. When you plug in -3/5 times 25, you get -15 plus 17, which is 2 kilometers. Alright, so 2, and then we have the last one, d of 30, 30 minutes. And I'm about to write 20 again. There we go. Now, this is an interesting one, because you get -18 plus 17 is -1 kilometers. What does that mean? You think about that for a second. I'm driving home from a football game. This is just showing, think about what this thing's modeling. It's showing as I drive, time goes up, my distance from home goes down. Well, you have to think, in real world, will we go negative distance from our house? Probably not. This means that we've already gotten home. And that we'd be home before 30 minutes. Because we would not count that. Now this one, when were you 7 kilometers from home? Again, we can use just do the solving. Set your d equals to 7, and now we want to find t. You subtract 17 and you get negative 10 is equal to negative 3/5 t. Hopefully you guys are good with, again, multiplying by the reciprocal, so you can solve for t with fractions, and you get t is equal to it's 50/3, and in this case, since we're dealing with time, we can say 50/3. It's approximately 16.7 minutes. And then finally, what does the slope represent in the real world? Well, first let's look at the slope. The slope is distance over time, right? It's y over x. So the slope is equal to the change in the distance from home in kilometers per time in minutes. That's all it is. The distance, change in distance from home in kilometers per time in minutes. Now, what do the time and distance intercepts represent in the real world? Alright, so remember, time intercept means when distance is 0, and distance intercept is when time is 0. Okay? So the time intercept is when the let's do the distance intercept first, when time is 0. If we look at our equation, the distance is equal to negative 3/5 times 0 plus 17. That means our distance is 17. What does this mean? Well, when time is 0, we are 17 kilometers from home. So our starting point, we are starting 17 kilometers away. That's what the distance intercept means. Starting 17 kilometers away. Now let's think about the time intercept. So now I'm going to set d equal to 0. I want to know what d equal to 0 is. And I'm solving for the t. And when you solve this, and again you can use your calculators, you should get t is approximately 28.33 minutes. And what does that represent? Well, when the distance is 0 in the real world, distance from home is 0, this represents the time that we made it home. Okay? So one of the intercepts is your starting point and how far you are away from your house. The time intercept is when you make it home. Sketch a graph, make sure to label your axes. Okay, so I'm going to do standard form here. And again, we only need, because we're dealing with the real world here, we only need the first quadrant. I don't want any negative values because I don't care about those. I'm just going to say that this is 17. And I'm going to say that this is 28.3, well, about 28. So that means 28.33 would be about there. And then again, this is distance from home. In kilometers. And this is time in minutes. And again, it's like doing a standard form graph. You have your two intercepts, graph it. It's a linear line, it's a linear equation that does that. Which makes sense. As the time goes up, you should be getting closer to home until you finally reach home. Okay, so that is just modeling just a line, just a linear equation. So that's stuff that actually you guys should be pretty familiar with now. It's just now we're dealing with word problems. Okay, if you want, you guys can pause the video right now and try number 2 on your own. Now, the only thing that's tricky about this one is the wording at the beginning. The wording at the beginning says, Handy Andy sells 1-gallon cartons of milk for $3.09 each, and half-gallon cartons for $1.65 each. Assume that the number of cents you pay, not dollars, cents, varies linearly with number of quarts. So, we're dealing with cents and quarts. So and it says cents varies linearly with quarts, so that means it's going to be C is your Y. Okay, and then the number of quarts is going to be your X. I'm going to use C and Q here. Why not? So C is going to be cents, and Q is going to be the number of quarts. Write an equation expressing price in terms of quarts. Okay, well we need to get 2 points first. We know that if we have 4 quarts, that the price is 309 cents. Again, I'm in cents. I know that if I have 2 quarts, that I'm going to have 165 cents. So now I can find a slope. Okay? The change here is negative 144. The change here is negative 2. So my slope is negative 144 over negative 2, or 72 cents per quart. Alright, so now I can come up with an equation. My cents minus, I'll use 165 and 2. Minus 165 is equal to my slope times Q minus 2. I am going to solve this. 72Q minus 144. Add 165. Our final equation is C of Q. Again, I'm going to write it in function form for you guys. 72Q plus 21. So that is a function telling me the number of cents depending on the number of quarts. Alright, so now if Handy Andy sold 3-gallon cartons, what would you expect equation to predict the price to be? Well, let's put in 3. Oh, but be careful. What did it say? It said 3 gallons. We want quarts. So 3 gallons, 1 gallon has 4 quarts, so 3 gallons will be 12 quarts. So that means that I'm finding the cents with 12 quarts. So C of 12, I want to know when 12 quarts what the cost in cents is. So 72 times 12 plus 21. And you should get 885 cents, or $8 then and 85 for the price. The actual price for pint cartons, so that's half a quart, and 1 quart cartons are 57 and 99 cents respectively. Do these prices fit your mathematical model? If not, are they higher or lower than predicted? Well, I'm telling you what they should be. You find out what they turn out to be based on plugging in. So I'll start with C of 1/2 a quart. Alright, and you should get 57 cents. So half quarts are actually exactly right on. This fits the model. Let's do full quart now. 1 quart. We have C of 1 is equal to 72 times 1 plus 21. You get 93 cents. So the model is saying it should be 93 cents. They are charging 99. So, do these prices fit your mathematical model? No. Are they higher or lower than predicted? We predicted to be 93, so for 1 gallon they're higher by 7, or not by 7, by 6 cents. Okay. So I just used my information to do that, and then solved. So it says for the for part D, suppose that you round cartons of milk marked at you found cartons of milk marked at $3.45, but that there was nothing on the carton to tell you what size it is. According to your model, how much should or would such a carton hold? So now I'm going to plug in 345. Again, make sure you're plugging in 345 because this is cents into my model. And when you solve this, I'll let you guys do that little math there. You should get it's about 4.5 quarts. So that would be about 4.5 quarts. So a little over a gallon. Alright, so sketch the graph with the slope and intercept in your equation. Alright, so this is number of quarts. 1, 2, 3, 4. And then this is cost in cents. And I'm going to just go, this is 400, this is 200, 300, and 100. We'll go from there. Now, when the number of quarts is 0, there's some random fixed cost, which is kind of weird. Probably because it has to, they have to make the cardboard. So the intercept here is 0, 21, because when you put 0 in for quarts, you get 21 cents. So the intercept here is 0.21. And then our slope is 72Q. But we also know one of the other points. The other point is 2,165. So I'm going to put that here. So this is 2,165. And that would be our line then. Okay. Alright, and then finally, what are the units of the slope? What real-world quantity does this number represent? Well, the slope is cents per quart. And what that represents, it's the unit cost of a quart of milk. Okay? If you have questions on these word problems, again, we were just doing the same things we were doing with linear equations, but you have to read carefully and follow the instructions to come up with the answers. You guys only have like 3 word problems to do in class. I might come up with more for you. We can go over this again if you had any questions.